Inaccurate estimates of project benefits can put your reputation at risk and call into question the value of energy efficiency efforts. That's why it's critical to ensure that your savings estimates are accurate when validating potential opportunities, developing business cases, or applying for incentives. All too often, energy savings estimates can be inaccurate because they're calculated using methodologies or rules of thumb that include assumptions that don't apply to your equipment. In this lesson, you'll learn a structure for estimating savings that will help you avoid the most inaccurate of savings estimates. The first 3 steps in this structure are assess available data, establish a baseline, and understand the savings mechanism. These steps will ensure that you have a solid understanding of your system so that you can move on to the final step, calculate savings. With this approach, you can be confident that your results are grounded in reality. Before you get started, you'll need to understand the level of accuracy you want in your savings estimates. If you're evaluating a small project or just want a ballpark estimate to see if the opportunity is worth exploring further, a low-effort estimate that has significant uncertainty but is still rooted in reality might be good enough. For a large investment, more detailed and accurate estimates may be necessary. Understanding how accurate your estimate needs to be will guide your decisions at each stage of the savings estimation process. A structured approach to estimating savings starts with determining what data you have. This will help you understand your equipment, what data are available to calculate energy consumption and savings, and whether you need more information to achieve the level of accuracy you need. Assessing your data availability typically involves gathering equipment details and specifications, understanding usage patterns, and identifying what parameters are metered and how those data are logged. It's likely that some data are missing. Energy consumption might not be submetered, data might only be available for certain periods, or data loggers may be missing information. Factors affecting energy consumption might not be monitored, and data might not be reliable. In some cases, equipment specifications or nameplate data may not be found, but knowing what is available will help you develop a critical understanding of your system and identify any gaps that need to be addressed to achieve the accuracy you need. Once you know what data you have to work with, you'll need to establish an accurate baseline of energy consumption. In most cases of inaccurate savings estimates, if the baseline energy consumption had been established, the savings would have appeared as an unreasonable percentage of total consumption, and the error would have been immediately obvious. To establish an accurate baseline, you'll need to estimate or measure the total energy consumption of the system you're investigating across all modes of operation. This means understanding the energy consumption of equipment over different seasons, production schedules, or types of operations. You'll also need to consider the equipment's runtime, duty cycle, and any operations at partial load. The baseline consumption can be calculated using a variety of information sources, depending on the equipment under investigation, from metered data to a combination of nameplate data and operating assumptions. Whether these factors are measured or estimated depends on the availability of data and your required level of accuracy, but either way, the baseline will provide guardrails to keep your savings estimates on track. Once an accurate baseline has been established, the next step is to understand the savings mechanism of your identified energy-saving opportunity. This means understanding how changes to the system, whether they're equipment changes, behavioral changes, or operational changes, affect how the equipment works and how those changes result in energy savings. Without this understanding, the calculations or methodologies you select to estimate savings may not reflect how the equipment actually operates, leading to under- or overestimation of the project benefits. Understanding the savings mechanisms within your system will help ensure that your assumptions and the savings estimated using those assumptions reflect reality. The final step is to identify appropriate savings calculations and recognize their limitations. There are a wide variety of savings calculation methodologies for any given system. These can range from general rules of thumb to engineering calculations or complex modeling. Understanding the data you have, your baseline consumption, and the savings mechanism for your opportunity will allow you to choose an appropriate calculation method that reflects how your system actually operates and evaluate whether the results of that calculation are reasonable. You should be aware of the limitations associated with various methodologies, including the conditions under which those calculations are valid and the assumptions used in these calculations. By applying this structure to estimate savings, you can be confident that your savings estimates are grounded in reality. In the next lessons, we'll explore how to apply this structured approach to various systems, focusing on their specific considerations.